Welcome to This Explainer. Today we're diving into a story that honestly feels like it was ripped straight out of a sci-fi thriller. We're looking at an AI model so incredibly capable, its own creators decided they had to deliberately lock it away.
Just imagine a hidden flaw sitting inside a highly audited, incredibly secure software system since 1997. It was completely missed by human experts for literally decades, just hiding right there in the code. That is, until something finally caught it.
And that something was Claude Mythose. This is a frontier generative AI model kept strictly internal by Anthropic, mainly because of the absolutely astonishing discoveries it made during testing. You're not going to find this on their website or kicking around on an API tier somewhere. This is an AI the public simply isn't allowed to use.
Section 1. Meet Claude Mythose, the autonomous researcher.
So what exactly is this thing, right? And why isn't it just another helpful chatbot you can ping for a quick code fix? Well, standard AI helpers give you quick answers. You ask a question, you get a fast back and forth. Claude Mythose, on the other hand, was built under Anthropic's internal project Glasswing for extended independent focus. We're talking hours-long autonomous research and multi-step agentic workflows. It formulates hypotheses, tests them out, and iterates entirely on its own.
Section 2. The Zero-Day Hunter. Finding flaws humans missed.
This sustained focus is exactly what led to its most alarming capability, finding previously unknown software flaws at a massive scale. Now, to really grasp the threat here, we have to talk about what a zero-day actually is. It's basically a software flaw that hasn't been publicly disclosed or patched yet, so developers have literally 0 days to fix it. It's incredibly valuable for defenders to find these first, but obviously a highly dangerous weapon in the hands of an attacker.
And Mythose autonomously hunts these down by acting exactly like a top-tier human security researcher, only way faster and, without needing a coffee break or sleep. It analyzes the code and compiled binaries, it identifies logic flaws, it chains those tiny little weaknesses together, and finally, it generates a working exploit just to prove the vulnerability is real.
During red teaming, Mythose didn't just find theoretical, maybe someday bugs. It found real, critical flaws in widely used software. Just think about this list of discoveries. It found a 27-year-old TCP bug in OpenBSD. It found a 16-year-old vulnerability in FFmpeg, which is used in countless media players. It uncovered a highly dangerous guest-to-host memory corruption bug, and it even generated working exploits for the Firefox JavaScript engine 181 times. These major flaws had been hiding in plain sight for years.
So how exactly did it pull this off? Well, it managed this by maintaining an enormous 1 million token context window. That massive memory means the model can basically hold entire, sprawling code bases in its head all at once, while it actively hunts for those interconnected flaws.
Section 3. Project Glasswing and Lockup. The dual-use dilemma.
Now, as undeniably impressive as those hunting skills are, they bring us to a massive dilemma. An AI this capable is amazing for defensive use, like proactively hardening national cybersecurity infrastructure and responsibly disclosing bugs. But let's be real, it's utterly terrifying on the offensive side. If criminal groups or nation-state actors get their hands on an automated zero-day hunter, the internet instantly becomes a very dangerous place.
Because of that exact risk, Anthropic flagged Mythose as ASL3 under their responsible scaling policy. What this means in plain English is that the model provides a meaningful uplift to actors seeking significant harm. Put simply, the current safeguards we have today just aren't good enough to safely deploy this to the public.
So instead of a flashy public release, it was heavily restricted. It's limited strictly to cybersecurity use and shared only with a heavily vetted coalition of 12 critical industry launch partners. We're talking companies like AWS, Apple, and Microsoft. If you aren't on that list, the only way to even glimpse it is through a highly gated preview on Amazon Bedrock, and even then, they kind of have to call you first.
Section 4. Evaluating the AI hype, fact versus fiction.
Of course, with so much secrecy, the sensationalism naturally starts to swirl. So let's cut through the noise and evaluate how dangerous this model actually is in the real world. The UK's AI Security Institute got to test it, and they found a really impressive 73% success rate on expert-level capture-the-flag tasks. But there's a pretty huge operational catch to that number.
Let's compare the perspectives for a second. Anthropic released a staggering 245-page system card showcasing all these incredible potentials and complex exploits. However, the UK AI Security Institute pointed out that Mythose mostly succeeds against poorly defended systems. When you put it up against real-world, actively defended networks that have modern security tools, it actually struggles quite a bit more.
And this is exactly why independent security experts like Bruce Schneier are maintaining a healthy dose of skepticism right now. We really need to balance the hype of this magical hacking AI with a grounded look at the actual evidence. Yes, it's a powerful tool, absolutely, but it doesn't just instantly break the entire internet with the push of a button.
Looking directly at the data from the OSS Fuzz corpus testing, out of thousands of targets, Mythose successfully caused nearly 600 minor crashes. Those are your tiers 1 and 2. But when it came down to tier 5, an actual full control flow hijack, it only achieved that on 10 specific targets. So it's super impressive for sure, but it's definitely not foolproof.
Section 5. Future of Software Security. Surviving the Vulnerability Wave.
Even with that reality check in mind, AI models like Claude Mythose are going to fundamentally change the daily lives of software developers. Because here's the real problem staring us down. The biggest immediate threat actually isn't some rogue AI hacker trying to break into the mainframe. It's the sheer volume of new vulnerability alerts. As AI accelerates how fast we find bugs, it's going to completely overwhelm human security teams with an absolute sea of noise.
To survive this incoming wave of alerts, teams are going to have to rely heavily on something called reachability analysis. Look, just because an AI found a bug in a piece of open-source code you happen to use doesn't automatically mean your specific app is vulnerable. Reachability analysis proves if that vulnerable function is actually executed by your software's execution path before your team panics and drops everything to go fix it.
Security firms like Endor Labs recommend these 4 practical steps for defenders. By inventorying your code, applying that full-stack reachability analysis, patching only what's targeted, and continuously verifying your coverage, teams can filter out up to 95% of the noise.
And that is absolutely crucial because it lets humans focus exclusively on actual reachable risks instead of constantly chasing AI-generated ghosts.
The very existence of Mythose proves that Anthropic's safety process actually works today. I mean, they built it, tested it, realized what it was, and locked it away. But it also proves that emergent capabilities are a very, very real thing. As these models scale up in general intelligence, the gap between a helpful coding assistant and a dangerous cyber weapon is rapidly shrinking.
And that leaves us with a pretty critical thought to end this explainer on. As autonomous AI gets smarter by the day, and as emergent capabilities keep surprising even their own developers, how long do you honestly think these safety boundaries are actually going to hold?